Good morning. Today we're going to be finishing off our proportional relationship and our direct variation. So if we recall from our last video, we talked about how a set of numbers are proportionally related if and only if they had a constant rate, which meant that I would take 2 points, exactly 2 points, I would turn them into a fraction, divide them, and if they came out to the same number, then they were proportional. If they came out to be different numbers or different decimals, then it was not a proportional relationship. We also learned that a proportional relationship, if I can say that, then if it is proportional, it has a direct variation. Okay. We talked, and one of the main things we talked about the fact that the equation that we'll use when we're talking about direct variation is y equals kx, which again, I said was the same thing. It's the same thing as y equals mx. It's just because when we're talking about a direct variation, we're talking about a constant rate. And when we're talking about slope, we're talking about a constant rate of change. And we'll go into that a little bit later, but that's why they say kx. All right, but it's very much interchangeable. So today we're going to tackle some of these word problems. And what we're going to look at here is we're going to remember how we did those word problems before. When we were doing those word problems before, we found that the m, the constant rate of change, which now we're talking about the constant rate, was always connected to the per whatever was happening consistently, right? $10 per hour, whatever it may have been. And then we always realized that the B was our initial fee or our starting point. So in any of these problems, they're all going to vary directly, which means there's a direct variation, which means that there's no B. So none of these problems are going to have a B in them because they all state that it varies directly. All right. So, but what you'll also notice is they don't always give us our rate. So our constant rate, if we think back, our constant rate, was found by taking a point and dividing it. If you remember, this rate was $6 per pound, and so our constant rate was 6 per pound. Okay, so today we're going to be talking about that too. So here we go. I'm going to grab my highlighter. The total cost for tickets to the dance varies directly to the number of tickets purchased. Bam, right there. Varies directly. That tells me this is a direct variation. And so it says the total cost for tickets varies directly to the number of tickets purchased. Now, if I think about that, that's actually really important. Total cost of tickets varies directly to the number of tickets. Now that's interesting. If we think back to our notes yesterday, I'm going to need my, this equation came from, it says, remember the y, oh, there it is. The equation reads, y varies directly as x. This actually helps us really a lot. The y varies directly to the x. Look at that. It literally goes in the exact order that we know. And so therefore, I'm going to know that my y is my cost and my x is my number of tickets. Perfect. Okay, so the next thing we're going to look for is that it says if 5 tickets cost, oops, I wanted to keep going. Cost $15, identify the constant of variation and write the equation to represent it. Well, the constant of variation is the constant rate. So I find the constant rate by taking a point, which is this five tickets for $15. And I make it into a fraction and I divide. So I'm going to take 15 over 5 equals, and I know 15 over 5 is 3, so $3 per ticket. $3 per ticket is my constant of variation. Okay. Why did you put 15 on top, Miss Schultz? Why did you put 5 on bottom, Miss Schultz? Well, if I think about it, whenever I've been doing slope or constant rate, I've always been putting y on top and x on bottom. My y is the cost. My x is the tickets. $15, 5 tickets. That's how that fraction came to be. So now, what is my equation to represent the situation? Oh, well, now I have to find it. Where did it go? Oh, there it is. Is y equals 3x. And so there we go. So first, it's identifying what's my x, what's my y. Second, I found my constant of variation, the constant rate. And then third, I made an equation. All right, let's do another one. Ready? Here we go. The number of teachers varies directly. Oh, there it is again. Varies directly to the number of students. Well, we can even look at how this is said. The number of teachers varies directly to the number of students. So which one's my y and which one's my x? My y is the number of teachers and my x is my number of students. Because again, the y varies directly to the x. Okay? So my y is teachers, my x is students. So now I'm going to go ahead and I'm going to say, let's continue reading. If there is one teacher per every 20 students, identify the constant of variation and write an equation to represent the situation. So let's figure out the constant of variation. That one's easy. One teacher, 20 students. Now a lot of you are going to want to put 20 over 1, which is not correct. Because I have to remember, my y is going on top. My x is going on bottom. So my constant of variation is 1/20th. Which for this, I'm actually, because we're talking about constant rate and we're talking about these varying directly, and we're going to go ahead and divide that and we get 500ths teachers per student. So then to write the equation to represent the relationship, I'm going to write y equals 0.05x. And you're going to ask me, Ms. Schultz, can I leave it as a fraction? It wouldn't be wrong. So I wouldn't ever mark it wrong, but for these, what we're looking for is we're looking for the unit rate. So we're actually dividing, so our denominator is 1. So it is important that you divide on these. So you're not wrong, but I want you to get used to actually dividing. Okay. Number 9, I want you to go ahead and try and pause this and give it a go. Oh, this one's a little different. Did you notice? So you should have noticed that, yes, it varies directly. You should have figured out that my y is the earnings, or you could have put like total money earned. I put earnings because it says the money earned, so I did earnings. And then it varies directly with the number of cars. That was my x. Then it said, if 4 cars are washed, $14 is made. So that means my constant of variation is 14 over 4, which is $3.50 per car. Now the next part of this doesn't say write an equation. Although I will. Oh, I gave you the whole answer. Nah, that's fine. Then it says, determine how much money is made when 15 cars are washed. Well, I created my equation, y equals 350x. And then I plugged in 15 cars into the situation, remembering that cars was my x. So I plugged it into my x. And I got out $52.50 would be made. All right. Number 10 is the same, or not totally the same. It's going to be a little different. Give it a try. See if you can figure it out. Pause. Okay. So for this one, again, it varies directly. It says the cost of apples is directly proportional. They use different terms, but guess what? They mean the same thing. The cost of apples is directly proportional to the number of apples purchased. So that means my cost is going to be my y, and the number of apples is going to be my x. It then says if 8 apples cost $2, oh, that's my rate. So I put 2 on top because that was my cost, and 8 on bottom because that was my apples. I divided, and I got 0.25 apples. Cool. So if I were to write this equation, what would it be? Hopefully you're shouting out y equals 0.25 x, and that would be correct. So now it says determine how many apples were purchased if the total cost was $4.50. Look at that for just a second. It says the total cost was $4.50. Cost is y. So I'm going to be plugging in $4.50 into my y. So I plugged in $4.50 into my y. So now I have $4.50 equals 25 cents x. How do I get my x alone? I divide. So I divide by 25 cents to both sides, and I get x equals 18 apples. So I'm able to use all of this information and then solve for problems that might happen in the future. All right. Graphs are probably the easiest part just because there's two things that you have to understand is that it's important to understand the direct variation is y equals kx. It's mx, right? Remember, it's like the same thing. It's a special type of linear equation because it just doesn't have the y-intercept is always going to be 0. And the slope is always, it's just the k or the m. It's exact. This information is exactly what I've been saying the whole time. So if I were to graph these equations, all 3 of them are going to be direct variations. I know this because all 3 of them have 0 as a b. And so that means, and they're all straight lines because all my x's are to that power of 1. So I've got my 4x, I've got my 2/3 x, and I've got my negative x. All of these very directly because if I were to take any point on this line, I could make a fraction and they would all equal each other. That's different for ones that don't vary directly. So this black line here, that one varies directly because it goes through 0. That black line there is y equals 2x. So y equals 2x. The blue line there is y equals 2x. Y equals 2x plus, I think I did 3. 1, 2, 3. Oh. Why is that doing it? Plus 3. I guess I just got to do this. Hold on. Why is it? There we go. Plus 3. And you'll notice if you went ahead and you plotted some of these points, you would note, like for instance, this point is 1, 2, right? Over 1 up 2. 1, 2 is going to be equivalent to 4. But they're the same thing. They're going to be equal to each other. But if I were to look at this one, what are my points here? Let's find one. 1, 5 is not the same as -1, 1. So they're not the same. So therefore, when we add that b, it changes and it doesn't direct vary. It doesn't vary directly. Okay. So again, what did we do today? We took these word problems. We found what our x and y's were. Now it's not letting me click. It found what our x or y's were. We found our constant of variation. We made equations. Then we came down and we found our x, y's. We found our constant of variation. And then we plugged in what the information that they gave us. That's what you're doing today. All right. Let me know if you have any questions, and I will talk to you all later. Have a good day.